Hello students, we'll continue with the same chapter, quadrilaterals. We'll move to part 7 now. This is section 7.5, the next section, another condition for a quadrilateral to be a parallelogram. Let us see what is that when we move forward. In the last video, we learnt one more property and proved a theorem, diagonals bisect each other and its converse. With this we have proved 3 now, that is 3 only for the parallelogram, besides angle sum property and 2 congruent triangles. In this video, we will see one more property. Let us see what is there in the next page. You are seeing one different heading, parallelograms, least requirement. Let us see what is that. We have so far seen that any one of the following conditions is to be satisfied for a quadrilateral to be a parallelogram. Each pair of opposite sides is parallel, basic requirement. Recall what you saw in the flow chart, first page. This is mentioned in the red within brackets. Then we saw the next property, that is each pair of opposite sides is equal, and also we proved a theorem for that 7.3, that is a converse. Then each pair of opposite angles is equal, theorem 7.5. Then diagonals bisect each other, theorem 7.7. So these 3 properties we saw in addition to the basic requirement. So 4 conditions we saw. If any one of these 4 conditions are satisfied, then we can call a quadrilateral as a parallelogram. Let us now see a 5th condition, which is the least requirement for a quadrilateral to be a parallelogram. What is the least requirement? That we will see again after we prove the theorem. Now this is a parallelogram, this is a quadrilateral. Given a quadrilateral ABCD with a pair of opposite sides is equal and parallel to each other. That is, here what is given? It's a quadrilateral is given, AB parallel to CD as well as AB equal to CD. Now here note, here it is only one pair and not both the pairs. As we saw in the previous page also, both pairs are to be parallel, both pairs of sides are to be parallel, or both pairs of sides are to be equal, or both pairs of angles are to be equal, or both diagonals have to bisect. It is not that one is sufficient. In all the cases, if you go back to the converse, you will know in each converse we have to finally prove that both the pairs. So here we are going to talk only about one pair, but only one difference is we are not taking any one, we are taking 2 conditions, that is equal as well as parallel. Draw diagonal AC. Now this is simple. These 2 triangles are congruent. Let me put the angle and also the color, and also I think, yes, now we have got one side each equal, one side is common and 2 angles equal because alternate interior angles with AC as a transversal. Because of this, 2 triangles are congruent, and since these 2 triangles are congruent, AD equal to BC. Now from this I think you will be able to understand what we are going to try now. So one side initially we have given, it was given one pair of sides are equal. Now we have proved another pair of sides also equal. That means what? Yes, when we go to next page, I know you have understood already, you got it. Let's go to the next page. Therefore, quadrilateral ABCD is a parallelogram because each pair of opposite sides is equal. We started with one pair of opposite sides is equal, but we are able to prove each pair of opposite side is equal. That means we saw that is one of the converse of the theorems. One of the theorems you have seen, I have not written the number, but you know if each pair of opposite sides is equal, then a quadrilateral is a parallelogram. Based on what we saw now, we get the following theorem. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. So it is only one pair here, but there are 2 conditions, equal and parallel. It's a combination of, you can say simply it's a combination of 7.3 and the minimum condition, minimum requirement, correct? Yes, if you go through the notes what you have written, you will be able to understand. So now note down this theorem also word by word in your notebook before moving forward. Let's move forward. So why it is called a least requirement? Let us see now. In all the 4 conditions we saw earlier, all sides or all angles or all diagonals have to satisfy certain requirements, correct? This is what I told in the last page. Whereas in this condition, only one pair of opposite sides have to satisfy certain requirements, and hence this is the least requirement amongst all the conditions. This I have already explained to you when we are proving the theorem. Sorry. So, you can note down this reason why we are calling this as a least requirement. We will move forward. So, in this video, we learnt another property, least requirement for a quadrilateral to be a parallelogram. A pair of opposite sides is equal and parallel. So, up to 7.7 theorem we have seen in quadrilateral now. In the next page, in the next video, we will practice some examples to understand the theorems learnt in this chapter so far. So, we will be seeing few examples in the next part or maybe in 1 or 2 parts next videos. We will use all the theorems we have seen so far, and so that we can understand further, understand thoroughly all the theorems. Note down the questions. Pause the video, note down the questions. That's all for this video. Thank you.